Welcome back. Mr. W here. All right, now we're going to solve with variables on both sides. So now we're going to get into this world where we have a variable term and a constant, an equal sign, a variable term, and a constant. So that means that we have to get the variables to one side and the constants to the other. And you can do that either way. A lot of kids will try to always move the x to the left-hand side, which is totally fine. Just be careful with that negative, if there is ever a negative. Me personally, I just move the smaller x term, because then most of the time that secures the x to be positive. So if we move the variables to one side, so you got to get the variables to one side, variable term to one side, right? And then that means the numbers to the other. That's what we're looking at. So hopefully that's it. There we go. All right, so we're going to subtract 2x from this side, and that means I'm going to have to subtract 2x from this side. Remember, we have to keep it balanced. Whatever I do to one side, I have to do to the other. So then 4 minus 2 is 2x. Then we bring down the plus 5, we bring down the equal sign, and we bring down the 19. Some of you all out there draw this line in here to sort of kind of remind yourself that you can't go past that line, which is awesome. Now it just looks like a normal equation here. Now we're going to subtract 5 from both sides. We're going to bring the 2x down. We're going to bring the equal sign down. 19 minus 5 is 14. Then we're going to divide by 2, and we're going to get x equals 7. All right, if we put that back in here, 4 times 7 is 28. 28 plus 5 is 33. If we put 7 in here, 2 times 7 is 14. 14 plus 19 is 33 as well. So 33 does equal 33, we'll take it. That's the first looking one that we would have on the variables on both sides. Now, we also have these different types of answers that we could come up with. And what do I mean by that is that what happens if they give us this crazy problem that looks like this, where now we have to do a little bit of distributing on one side, we have variables on both sides, right? So what we have to do is we have to take this 3 and we distribute it. We get 3x plus 12 plus 2x is equal to 5x plus 12. Now we see that we have like terms over here. So 3x plus 2x is 5x plus 12 is equal to 5x plus 12. Now we have to remember that we have to get the variables to one side and the numbers to the other side. So that means I'm going to subtract 5x from this side and subtract 5x from this side. And notice that all of a sudden my x terms go away. And I'm only left with 12 equals 12. 5x minus 5x goes away. 5x minus 5x goes away. So I'm left with the 12 equals to 12. So now we have to ask ourselves, is this true? Is this true? And if it is, which 12 does equal 12, that means that there's infinitely many solutions. Meaning that I could throw any number in the world, any number that I can think of will make this a true statement, right? Anything, million, 2 million, negative 745,000, doesn't matter. We can put that into the x and it will still stay true that 12 equals 12. So this is a different type of answer, and this sometimes is going to be your answer, is infinitely many solutions. So we call this type of problem one solution because the only solution is the 7. This is infinitely many solutions. That means that it can be 7. It could be anything. Infinitely many. The last one that we're going to talk about is Still looks very similar to this problem, but we're going to just change it up just a little bit. So we're going to have 3 times x plus 3 plus 2x is equal to 5x plus 12. All right? So again, we're going to take the 3 and we're going to distribute it. We're going to get 3x plus 9 plus 2x is equal to 5x plus 12. We're going to combine like terms. 3 plus 2 is the 5. So 5x plus 9 is equal to the 5x plus 12. And then we're going to subtract 5x from both sides. And that means that we're left with 9 is equal to 12. So again, ask yourself, is this true? In this case, 9 does not equal 12. Nowhere, no how does 9 equal 12. So since this is false, then we would say our answer is no solutions. No solution. Because there's nothing in the world that we can plug into right here. Look right here. Nothing I can multiply by 5 and add 9 to it and come up with the same number as when I multiply it by 5 and add 12 to it. Wouldn't this side always be 3 ahead? So there's no way that we can get anything in here. So that means it's no solution. We call these special answers here, right? Special solutions here. No solutions. Then we have infinitely many solutions when 12 is equal to 12 or when these two things make sense. And then we have one solution. Those are our 3 types of solutions. All right? See ya.